Thundercunts. We're here live. Gonna give you the 20-minute lecture. We're trying to spruce up the channel, like I said, at high speed. Uh, getting some things going. But what I figured we'd do is spend a little time cracking the old book and talk about testing of polyphase induction machines. Now, why is the testing of polyphase induction machines important? Well, we're going to talk about it. The proof of guaranteed performance, the determination of torque or efficiency of driven machines, and the evaluation of design changes are some of the purposes that require accurate tests of induction machines. Normally, running light, locked rotor, resistance, and dielectric tests are only made on standard motors. Input output tests or segregated loss tests are made when accurately, efficiently determination is required. So, pretty much, we're talking about the induction machine. And the induction machine comes in the form of an inductor. And you see right here is a ferrite core. You get a couple winds around it. And it's one of those things where they can come in different sizes, they can come in different shapes, and here's one right here. Like I said, some of them are wrapped in tape. Some of them are pretty fucking small. Pretty much, they go around an EMF. But we'll talk about that later. That's going to be for another talk. Like I said, we've only got 20 minutes to talk, and we've got a lot to talk about. Okay. So, running the light test. The motor is run at no load with normal frequency and voltage applied until the watts input becomes constant. On slip ring motors, the brushes are short circuited. Readings of amperes and watts are taken at one or more values of impressed voltage phase voltages, and a sine wave form of voltage are necessary for good results, requiring operation of the test alternator and transformers well below magnetic saturation. Now, are you people familiar with electricity? Do you know what a sine is, the cosine, the tangent of, the electric lines of life? The magnetic flux that kind of permeates through the body and the soul and the mind and the atmosphere and the earth. And the reactance component is normally one of these things that get kind of hairy carry. And we've got the formula right here, which is x equals the square root V2 over 3I2 minus R2. And you can get you a look at that if you don't believe it. So, let's talk about frequency changes. The cycloconverter. Never forget about the cycloconverter. You know, it's one of those things that you gotta do when you're down and out. The cycloconverter is another type of electronic frequency charger, suitable for conversion to a lower frequency that has been tried experimentally. The simplified circuit arrangement for three phase is shown in figure 7. This system requires no capacitors for commutation since the K bar are supplied from the AC line. This, however, resulting in a low input power factor. The grid voltage or the igniter firing voltage is taken from the supply line but the phase angle is so controlled as to form a lower frequency waveform portions of the supply voltage wave. This system is capable of supplying any frequency from 0 up to at least 1/3 of the supply frequency. So, for those, you talk about the 60 cycle supply transformer, and they talk about alternating current, and that's one of the toughest things for me to get. It's hard for me when I look at the oscilloscopes. This reminds me back when I started thermodynamics and meteorology, the clouds. I was all huff and puff about the cloud, and I was misreading the weather. You know what I mean? You look at it and you think it makes sense, but that's not the fucking way it is. You understand? So, in this case, what we have is a sine wave. It says this is arm. You know, typically you have a light switch of power. You have hot, your power's on, or your power's on. All right. Now that may be a square wave on the oscilloscope. That's another thing. A wave, I guess, indicates frequency. So frequency is measured in hertz. It's how many times it oscillates. Now, oscillation is another one of those Warner von Braun things. That you kind of got to get outside yourself. You know what I'm saying? But it does like this. Pretty much, you can have you hook this shit up to what's called an oscilloscope, and it'll show you these waves and curves. And they say alternating current goes forward and backward 60 times per second. Now, this is what really stuck in my craw, and I never could. I'm still on the hunt for that deuce. How does it go this way and back that way 60 times per second? I thought it was a con. I thought it was a lie. To me, it says it's on and off 60 times per second. So it's emitting a pulse of electricity 60 times per second. It's on 60 times and it's off 60 times. It's 120 cycles. But when you're looking at the three phase, right here, what they did is they overlapped the waves. They have one wave go up and come down. And when that wave's coming up, they get another wave that comes up and comes down. And then they get another wave. He comes up and he comes down. And that is essentially where you get your three phase. And it just is a wavy thing. You still here? All right. We are 10 minutes in. We're only going to give you about 10 more minutes. Like I said, I'm trying to stifle up some loot. Um, if you followed my quest, storm season's off. I'm parched out here. It's summer. Storm season's dead. And the man has his boot on my neck. The proverbial man. You know, it's not any individual or entity, but we could use a little assistance. Okay, so capital expenditure. The distribution of capital expenditures by private utilities for the years 1937 through 1946 budgets about $900 million. $900 million. And is exceeded only by the capital expenditures of 1930, which amounted to about $919 million. Government expenditures for 1946 have been estimated at about $100 billion, which is not included in the preceding figures. Now that's old times money, 1946 money. You could imagine what that is today. And just to give you a little loaf, I'll even let you take a peek. Take a look at that there graph, and you'll see the things that you know happened over those years, the budgets of the expenditures, and the investment in the infrastructure, and the 60 hertz sine wave cycle. I'm telling you, there's something to it. It's an oscillating wave, and a lot of people don't get it. A lot of people can't wrap their mind around it, and I'm telling you, it takes time to really sink in, and it takes getting outside yourself. And I'm trying to figure it out. It is hell on earth, but it's a beautiful thing. You know, if you can figure it out, you can help a lot of people. And I figured I'd dip into my bag and show you one of these cool things. I found this. This is some wicked type of capacitor, man, that I found. It's a big one, you know. And these things, I've been studying up on them, and pretty much what they do is, you know, they hold the current in, and it's kind of like a battery bank, but it's not a battery. It's a battery, but it's not a battery. It's like the battery that has the amps. Now, amps is the, you know, and I could be fucking lying to you. Volts is the, yeah, is the, you know, the voltage is, you know, there's a lot of different things. There's amps, there's ohms, there's henries. And if you're not on it, you're a fucking loser. You're a fucking dog shit loser. So I hope you'll help and you'll get on the fucking train. Otherwise, you're going to section 13. You don't want to go there. Let's talk about transmission systems. Modern AC power systems usually consist of the following elements. One, generating stations. Those are going to be your power plants, your wind farms, your nuclear, your solar, your coal, natural gas, etc. Your hydro or your thermal, your geothermal. This is your source. This is your source of your power. Then two is your step up transformer stations. I guess what they do, I could be a fool. Check out the TVA. They step up the voltage. And then three is the transmission lines. That power has to go down the lines. And you'll see those lines, and they claim that the AC power is better for transmission than the DC power. But the longer the cable is, it loses energy as it travels. I could be wrong about that, but that's what I've been told. It loses energy. It takes energy to travel through that fucking line all the way down the line. And it can be hundreds of miles, thousands of miles. You never know. So, uh, you know, those are your three, your transmission lines. And then you got your four, which is your switching stations. Your switching stations, I guess, you know, separate it to individual places or factories or businesses or, what have you. Your five is your step down apparently does is like, these power poles, I guess. They talk about 220 or 120, 240 or 120, you know, you name it. It's super high power voltage up there, super high power, and they got those fuckers sitting up there in these tanks of oil, I guess, up there, and they stifle it down. They wringle it down into you know you know what I'm saying, usable voltage. You don't want to plug in you plug something too powerful in there, you blow up your phone. Check out the Electro Boom guy. He's a cool guy. And when you go through that period, you're coming all the way down to the primary distribution lines, number six, your service transformer banks, number seven, and eight, your secondary lines or networks. So these are pretty much the distribution and the transmission of electrons. I always said, I had a nightmare once about Jesus and the devil and all these prophets, and they were all up there. And they were, I died, and they were up there, and they had bags, and they were selling souls. Many of the people that they had their souls, and they were beggars in the street. They're just trying to sell people's souls that believed in them. Now, if you can wrap your mind around that, or whatever religion or deity you believe in, your little soul or whatever bullshit, you believe in is a warped flesh log, trash producing system. Uh, Understand that that soul is similar to an electron. Um, it, it has energy, and there's millions of these things, and they just fly through these fucking cables. And it's one of those things that the electricity is where it's at. And if you're interested in hanging out, click subscribe, and I'll see you on the next episode.